Position of a particle as a function of time is given by r equals 5.0 I hat plus 4.0 j hat t squared meters, where t is in seconds. Part A. Where is the particle's distance from the origin at t equals 0, 2, and 5 seconds? So one of the first things I note about this problem is the usage of unit vectors. Unit vectors are basically just a way to decompose a vector into its x and y components. So you can see j hat represents 1 unit in the y direction, and I hat represents 1 unit in the x direction. So that relationship allows for the Pythagorean theorem to be helpful if you would like to solve for that actual vector that those unit components represent. So you can see on the right where I have that triangle laid out, the 90-degree triangle, and you can see that hypotenuse value can be solved by square rooting a squared plus b squared. And we're going to be doing a lot of that calculation for both part A and part C. So let's look at what that looks like. So once again, we're solving for the particle's distance from the origin as 0, 2, and 5, and since this equation that was already given is a distance equation, we can just plug those in. So plugging in 0 is the easiest. You're not going to have to use the Pythagorean theorem. It's just going to cancel everything, and yeah, the particle will have moved 0 meters from the origin at t equals 0 seconds. Okay, so now we are using the Pythagorean theorem. So once you plug in 2 seconds, you square it and get 4, and then you factor the 4 into the unit vectors, and since the I hat represents the x and the j hat represents the y components, we can use those to solve for that vector by square rooting square rooting the 200 squared plus, or not 200, 20 plus 16 squared, which comes out as 26 meters at t equals 2 seconds. So it's just exactly the same per 5 seconds. You use the same math. And you end up with r equaling 160 meters. So it's 160, the particle is 160 meters away from the origin at t equals 5 seconds. So part B is asking us to find an expression for the particle's velocity as a function of time. So we know from our 1D kinematics units that velocity is the slope on the position graph. So what we know we can use in order to solve for slope is differentiation. So that's what I'm going to do here is differentiate that original position function or position equation we were given. Once you do that, you just use the power rule to subtract a power from the t and pull that 2 into the front. Then I just factored that 2 back into the vector component expression, and it ends up being, our equation ends up being v equals 10.0 I hat plus 8.0 j hat just times t. So that is going to be our final differentiation for part B. So part C is asking what is the particle speed at t equals 0, 2, and 5 seconds. So you can already see that this is going to be very similar to part A, just using our new expression that we saw for in part B. So 0 seconds is just going to cancel everything out, so the velocity is just 0 meters per second at 0. At 2 seconds, I didn't show it here on accident, but you do use that Pythagorean theorem relationship in order to solve for the velocity being 26 meters per second at t equals 2 seconds. And then at 5, it's the same thing, and it comes out as 64 meters per second at t equals 5 seconds. So that is going to be the final answers for part C of this problem. Thank you for listening.